it's important as well for you to be aware that when it comes to functions, the set of all the input values has got a name, okay? It's called the domain. So in grade 10, we introduced to the concept of the domain. The domain is just the set of all the x values, okay? It's the set of all the x values, okay? The domain is a set of all the x values. Now, the corresponding set for the output is called a range. Right? So the range is the set of all the y values. Now, it's important, I'm going to repeat this, that you need to be aware that for any relationship to be a function, you must have one output value. Can't have two, can't have three or more. Only one. But you can have more than one input value. But those input values must always give you one output. Okay, so if you look at the first part here in terms of an example, there. Let me recalibrate this. All right. So when it comes to functions, we have got two types of functions. We have got what are called one-to-one functions, whereby you have one input giving you one output. Right? The most common example of a one-to-one function is the linear function. Okay? That's the most common. Right? So we have got one-to-one functions whereby one x value gives you a what? One y value. Right? Now when you do a mapping diagram, okay, you get something like this for one-to-one. Okay? You get something like this, whereby each x value or each input value gives you one corresponding output value. So we call this type of a relationship a one-to-one relation. Okay? We call it a one-to-one relation. And be aware that these values here, they are your domain, that is the set of the x. And then these values will be the range, the set of the y values. Right? Now, it is also possible that you can have what's called a many-to-one function. Okay? By many-to-one, we are saying there is more than one input giving you the same output. Remember, a function is only a function if you only get one output. So you can also have a case here. I don't know why my beam. It was working well in the previous lesson. Okay, allow me to recalibrate this. How does that cause someone to laugh? Okay, so I'm saying if you have got a many-to-one relationship, can I have your attention? If you have got a many-to-one relationship, what it means is that you can have a case where one input will give you, two inputs or at least two inputs will give you one output. Like in this case here, we have got one output there, but there are two input values there. Okay? Such a relationship is called a many-to-one function or a many-to-one relation. Okay? Many-to-one relation. Okay? There are two input values giving us the same output. Right? So, for all our functions, okay, before I answer you, for all our functions, we only have two types. One-to-one functions and many-to-one functions. there is no function which is one to many. Okay? Any relationship which is one to many is not a function. So you can't have one input and then you get more than one output and you call that a function. That's not a function. Okay, so that's what we have here. So we have got one-to-many relation. Please, it's a one-to-many relation. It's not a function. Yes. So here we have got a situation where we have got one input giving us two outputs. Because of that, that relationship is not a function. Okay? So there are only two types of functions: one-to-one functions like linear functions. Then we have got many-to-one functions like a quadratic function. Okay? Later, we are going to learn under calculus about a new function which is called the cubic function, which is a many-to-one function. Right? And under this topic, you will also be introduced to a new function which is called the logarithmic function, which again, it's a one-to-one function. All right? So that's what you have here. I've discussed quite a number of things, right? Some of the stuff you know it from last year. Now, you can get a question in a test asking you to state whether a function is one-to-one or is many-to-one, or whether to state whether it's a function or not. All right? Then, can I have your attention? All right, before I carry on, what was your question? All right. Now, in maths, we have got two tests that we can use to determine whether a graph, can you pay attention? To determine whether a graph is a function or not. We also have another test which we can use to determine whether the graph is a function and what type of a function it is in terms of one-to-one or many-to-one. So let's start with the vertical line test. Now, this is the one which we use to determine whether a graph is a function. Okay? So we use this to determine whether a graph is a function. Okay? At this stage, we are not worried about what type of a function it is, whether it's one-to-one or many-to-one. We just want to know whether the graph is a function or not. So we use the vertical line test. Now, unfortunately, I don't have my stick, which I normally use when I finish this part. So what I'm going to do, I'm just going to use one of, can I have your attention? I'm going to use one of my digital tools to do that. So, with the vertical line test, if I sketch, okay, if I draw, can I have your attention? Let's say if I draw a simple quadratic function, can you stop talking? If I sketch a simple quadratic function, like this, okay, don't worry about its equation, we can just call it f of x, okay, right? If I want to prove that this quadratic function is indeed a function, I can perform what's called a vertical line test. Now, with the vertical line test, it works this way. Okay, allow me to change the color there. Right. So, if I draw the vertical line like that, okay, can you stop talking, please? So, something sounds like you need. Open the window. Open the window. Hey, can you open the window? Just open the window since you are closed. Alright. Okay, so with the vertical line test, right, you just have to take a vertical object, like in this case, this line which I have here. Like I wish I could change the other color, but it will take more time. So if I move this line, okay, if I move this line, say in a vertical, in a horizontal direction, like this, right? If you stop talking, at this point here, where that line intersects with the graph, there is only one x value corresponding to one y value, right? If I move it again to another point, right? Let's say to that point here in the third quadrant, right? If I move it there again, there's one there, right? So if I go to that point where the vertical line intersects with the graph. Again, I'm going to have one x value corresponding to what? One y value. Okay? That is an indicator that indeed the quadratic function is a what? A function. Okay? By using the vertical line test. And it's not, okay, at this stage, let's not worry about what type of a function it is. Right? I know that it's many to one, but let's not worry about that. We just wanted to test if it's a what? If it's a function. For it to be a function, there must be one x value corresponding to one y value. Right? So here, because the vertical line is intersecting with the graph at one point, that's an indicator that the graph is a function. Now, if you want to determine whether it's one-to-one or it's many-to-one, we use the horizontal line test. So, we use the horizontal line test to determine if a graph is one-to-one or many-to-one. Many-to-one function or relation. Okay, now with the vertical line test, it's the opposite of what I was doing now. So allow me to delete this. Okay, let me go back here. And then, okay. So, if I draw a horizontal line like this, like that, I can use that horizontal line to test if the graph is a one-to-one function or if it's a many-to-one function. So all I have to do is move. Let me move it a little bit so that it is more horizontal. Better now, isn't it? So if I move this graph down, let's say if I move it here, right? I'm sure you can agree with me that here we've got an x value, okay, corresponding to a y value there, and also here we've got another x value corresponding to the same y value there. So how many x values do we have? Two. And how many y values? One. So the quadratic function is a many-to-one function. Alright? Because we have two values of x giving us the same y value. If I move it again further down, say somewhere there, right? Again, at this point there is an x value, at that point there is an x value. So we have got two x values giving us the same y value. Therefore, the quadratic function is a many-to-one function. Right? Linear functions are one-to-one functions. Yes? Okay. Linear functions are one-to-one. Right? Well, let me show you how I know that. Okay? Can I carry on? Can I carry on? Yes. Right, let me go to the next page so that I can sketch the linear function. So if I go to the next page, and I've got the tools, so I'll try to use the tools nicely. I'll use that. Okay, then right, obviously this is x, and that will be y. Okay, don't worry about that. Then, if I sketch a linear function, let me use this line. If I sketch, can you stop it and pay attention? If I sketch a linear function with a positive gradient, like that, okay? That's a linear function. At this stage, don't worry about its equation, right? We can just give it a name, and maybe we can call it g of x. Okay, we can call it g of x. Now, if I want to prove that this linear function is indeed a function, again, I just have to use the vertical line test. Okay, so I can draw my vertical line. I don't like this color. Okay, but blue is my favorite. Yes, blue is my favorite color. Right here is black. All right. So I want to use the vertical line test to prove that the linear function is a what? Is a function, not one-to-one. It's a linear, is a function. So if you look, the vertical line test, it's all about how many points the vertical line intersects with the graph. So I'm sure you can see here that the intersection is only at one point, right? And that point is there. They intersect at one point. If I move that vertical line to the right, okay, like that, again, they will intersect at one point, which will be there, right? If I move it further, for the last time, right, they will intersect at the same point, which is there. So the vertical line is intersecting with the graph at only what? One point. That's an indicator that the graph is a function. If say, okay, I'll give you an example of a circle, which I'll just show you just now. If say the vertical line had intersected with the graph at two or more points, then it means it's not a what? A function. Right? So this is a function. Now let's prove that it's a one-to-one function. So if you want to prove that it's a one-to-one function, then I have to draw a horizontal line. Okay? Draw a horizontal line like that. Okay? I'm sure you can see that the two, that is the horizontal line and the graph, they intersect at one point there. If I move it down, like that, again, they are going to intersect at one point, which is there. Okay? This is an indicator that the linear function is a one-to-many relation, because every time you have one x value, you always get one y value. So our linear function is a one-to-one relation. Okay, it's not the only one. Also, the exponential function. Can I have your attention? The exponential function is also one-to-one. Later, we'll do the logarithmic function. It's also one-to-one. Okay. Yes. Which part? We use the vertical line to prove whether the graph is a function. right? Let's not worry about what type of a function it is, but we just want to know whether the graph is a what? A function. That's the vertical line test, right? The vertical line test is for proving that a graph is a function. Then the horizontal line test now is for proving whether the graph is a function, but what type of a function it is. Is it one-to-one or is it many-to-one? Okay. Yes. Yes. The vertical line must intersect at one point with that graph. All right. It's not okay. You see, if you define it as one x and one y, it's not entirely correct. It's about the number of times the vertical line intersects with the graph. They intersect what? Once. Then, if you want to know, can you pay attention? If you want to know whether the graph is a one-to-one relation or it's a many-to-one relation, use the horizontal line test. Okay? Right? Okay. Can I carry on? All right. So, like I think I'm done there. This is more like the introduction, by the way. Right. Whilst I'm still there, I just wanted you to be aware that functions are a very important topic in Maths paper 1. Right? Most of the marks on functions is grade 11, which you have done already. Right? The grade 12 component will only have one question. Okay? But the linear, the quadratic, the hyperbola or exponential, we have more marks. Okay, the whole topic contributes about 35 marks in paper 1. Out of those 35, maybe I would say an average of about maybe 10 marks will be the grade 12 component. The rest is grade 11. And that's what you encounter in your June examination. Because June examination will tell you are going to be tested on both grade 11 and grade 12 functions. All right? Okay, let's move on to some examples here. Right? Some examples. So the exercise says, determine whether each of the following relations, please be aware they are relations, okay? We don't know whether those relations are functions or not at this stage, right? Is a function or not. If the relation is a function, determine whether it is one-to-one or many-to-one. Also write down the domain and the range of that relation. Okay? So let me just zoom this for the sake of those who have got eyesight issues. Okay, so if you start with the first one, can I have your attention? Can I have your attention? The first one, right? There is no graph drawn. Okay? There's no graph drawn. I hope you can see that. But it doesn't mean that we cannot join those points. It is possible for us to what? To join the points. So, if we want to determine whether this is a function or not, we just have to be aware that for every x value, there is one corresponding y value. So for a, this will be a what? A function. Okay? That will be a function. Okay? Why is it a function? Because for every x value, we've got one corresponding y value. Because this is not, in fact, the points are not joined to form a graph. We cannot use the vertical line test in this case, but we can use the definition of a function. Okay? So that's a function. Now, since it is a function, we now need to determine whether is it one-to-one or is it what? Many-to-one. Right? Now, if it is one-to-one, it means there is one x value corresponding to one y value, which is true. Okay? Was 1, 2, 3 points. There's one x value and there's also one corresponding y value. So this is one-to-one. It's a one-to-one relation. Okay? Are you following? Then, since we have said it's a function, then we need to determine the domain and the range. Now, I want you to be aware that based on the information that's here, we have 3 points, so we can start from here in terms of the x value up to there. Okay? So our minimum is going to be -3 for x, and our maximum is going to be what? 2. So when I write the domain, remember when you write your domain, you start with the minimum, then the maximum. Now, depending on the notation you prefer, I am going to just use brackets. So this will be x is an element. We need to include this minimum here. So I'll put square bracket. Right? I hope you remember this from last year. So this will be from -3 up to 2. Okay? If you decide to use the inequality signs, then it will be -3 is less than or equal to x is less than or equal to 2. Right? Then the range, okay? The range, you identify the minimum, which in this case is 0, the maximum is 5, so that would be y is an element. We are starting from y equal to 0 up to +5. Okay? This is not new. Did range grade 10, domain grade 10, in grade 11 as well, you did the same. But let's come to the linear function. Right? Let's come to it. Now, please be aware that this first graph here, or rather, it's not, these are just points on the Cartesian plane. It's not a graph. But if you join them, you end up having a what? A graph. The points that are here on B are the same as the points that are on what? On A. So everything we wrote here for A also applies to what? To B. But the difference now comes when it comes to the range and the domain. Are you following that? The range and the domain here is not the same as here. Okay? Because we don't have a specific value which is a minimum and a specific value which is a maximum. So this is a function, and it's also one-to-one, right? But the domain, okay, we are going to start from -infinity up to positive what? Infinity. How do I know that it's because of this arrow here and that arrow there? So I can write this as x is an element of real numbers. Okay? Are you following that? Right? And then the range, right? This will be y is an element of real numbers. These 3 points, 1, 2, 3, are just 3 chosen points that have been used to draw that straight line. But it doesn't mean that x starts from -3 up to 5. And it doesn't mean that y starts from from -3 to 2 and y from 0 to 5. That's why the domain and the ranges are different. Okay. All right. The quadratics now. All right. Let's talk about this one. Right. At this stage, can you pay attention? You no longer need to stress yourself about the quadratic function. It's a function. Okay? And what type of a function is it? It's a many-to-one function. Right? It's many-to-one. Then we now need to write the domain. Right? The domain. Now, the domain of this quadratic function will be what? Huh? Will be what? The domain. What does this mean? Where are we starting? -infinity. And this means we are moving up to what? Positive infinity. So the domain there, okay, can I have your attention? The domain, you can write this x is an element. You are starting from -infinity up to positive infinity. That's the domain. Can you pay attention? Pay attention. Then the range. What's the minimum value of y from this graph? It's 0. So our range with y is an element. We are starting from y equals 0, and the 0 is included up to positive infinity. Okay, please be aware that there is a square bracket here to indicate that the 0 is included, because positive infinity is not a specific value. We don't put a square bracket there. Okay, I expect you to be aware of that at this stage. All right? Okay, so I think in my introduction to this lesson, we'll stop there.